is h comma k. That we went over yesterday. We get our h from the inside of our parentheses and our k from outside of our parentheses. And we have to change the sign of our h. The new thing that we're learning today is our axis of symmetry. So our axis of symmetry goes right through the vertex. It is a vertical line that goes straight through the vertex, and its x is equal to h. So we get that x is equal to that number from our h in our vertex. So x is equal to h, and it's a vertical line for our axis of symmetry. So our axis of symmetry divides our parabola into mirror images, and it passes through the vertex. So what we have on the right side of our axis of symmetry, we're going to have the same exact thing on the left side of our axis of symmetry. This is the third slide. So example 1. So we need to label the vertex and axis of symmetry and graph it. How do we find our vertex when it's in vertex form?
H comma x.
H comma k.
Yeah, okay.
And what's our h comma k here?
3 and 4.
Remember, we have to change the sign of what's inside the parentheses, so this becomes -3 and 4. And then what is our axis of symmetry?
-3.
Perfect. We get it from the same x in our vertex. So this is -3. So now we can go to our graph. We are going to go to the left 3 and up 4 and put our vertex right there. Aiden, looking at this graph, do we know if it's going to open up or down?
It's going to open up down because it's a negative.
Perfect. The negative out front tells us that it's going to open down. Now to find other points on our graph, we need to plug in numbers. So what is a number we can plug in here to find another point on our graph? What can we plug in for x to find some points on our graph? -1. You could literally plug in anything for x, but we want to kind of stick close to the axis of symmetry. So -1 works. So let's plug in -1. So we have -2 times -1 plus 3 squared plus 4. -1 plus 3 is 2. 2 squared would be 4, and 4 times -2 is -8. So -8 plus 4 is +4. So our point here is going to be -1, comma 4.
How is -8 plus 4 +4?
-4. You're right. Good catch. Thank you. I knew I did something wrong. So -4. So our point is -1, -4. So we're going to go to the left 1 and down 4. Now we don't even need to plug in another point to find a point on our left side of our graph. What is another point on our graph have to be? What does another point have to be?
-5 and -4.
Perfect. -5, -4. Since we're 2 spaces away from our axis of symmetry on the right side, we need to be 2 spaces away on the left side. And since we're already at -3, we just go 2 more spaces to -5. and then we just have to stay at the same height as -4. So once we have our 3 points, we just connect them with our parabola. Any questions here? Yesterday we focused on vertex form of our quadratic function. Today we're going to do vertex form and standard form. So our standard form of our vertex is this f of x. Our standard form of our function is this f of x is equal to a times x squared plus b times x plus c. So this is standard form. And our a, b, and c come from the coefficients in front of the x squared, in front of the x, and the constant. So this is our a, b, and c. And then we know that this here is vertex form. So it's a little bit harder to identify what our vertex and what our axis of symmetry are in standard form, but we have a formula for it on the next page. So our formula for the axis of symmetry when our function is given to us in standard form is going to be this x is equal to -b over 2a. So this is our formula to find our axis of symmetry. And then our formula to find our vertex when it's written in standard form. We get our same x-coordinate of our vertex from our axis of symmetry. So again, even if it's in standard form, we have that same first value in our vertex comes from our axis of symmetry. And then to find the y value in our vertex, we just take the x and plug it into all of the x's in our function. So we're going to do lots of examples of these. Also, an important thing to note here is our y-intercept. So where we cross, so where our graph crosses the y-axis is going to be that c in our function. So our c is our y-intercept. It's where our graph crosses the y-axis. And it's also when x is 0. So our point for our y-intercept is 0, c. One last thing to note here, when our leading coefficient, so the coefficient in front of our x squared, when it's a positive number, so when a is greater than 0, that means we have a positive number. Our parabola is going to open up, so it'll look like a smiley face. When our leading coefficient is less than 0, it is a negative number. So our parabola opens down, and it's going to be a sad face. So we can always tell in what direction our parabola is going to open, whether it's going to open up or open down, just by looking at that leading coefficient. All right, this brings us to our first example. So here we have a function. In standard form. So we need to identify our vertex, our axis of symmetry, and the y-intercept. And then we need to graph it. So our vertex is going to be a point, and our axis of symmetry is going to be x equals some number. What is the formula we need to use to find our axis of symmetry?
Negative b over 2a.
Perfect. Negative b over 2a. So this is what we use to find our axis of symmetry. And we get our a and b from our coefficients in our function. So our a is 3, our b is negative 6, and our c is 1. So we're going to plug that in. So we have negative 6 over 2 times a, so 2 times 3. Negative 6 becomes positive 6. 2 times 3 is 6. 6 divided by 6 is 1. So our axis of symmetry is going to be x is equal to 1. What is our first value in our vertex going to be? 1. It's the same thing as our axis of symmetry. And then to find our y value in our vertex, we need to take our x value and plug it into all the x's in our function. So we have 3 times 1 squared minus 6 times 1 plus 1. So I just took this value and plugged it into all of the x's. So we have 3 minus 6 plus 1. 3 minus 6 is negative 3. Negative 3 plus 1 is negative 2. So our y value is negative 2. What is our y-intercept here? One. It's going to be 0, 1, because our y-intercept is when x is equal to 0. So our point for our y-intercept is going to be 0, 1. And we get that 1 from our c. So our y-intercept is just 0, c. And we just take our c and plug that in. Now we can go to our graph. So first thing we're going to do is graph our vertex. We need to go to the right 1 and down 2. So that's the point of our vertex. Our axis of symmetry goes right through that point. And then we can graph our y-intercept as well, which is 0, 1. So we stay at 0 and go up 1. Now our axis of symmetry tells us that whatever we have on the left side of our graph, we're going to have the same exact thing on the right side. So if this point here at 0, 1 is 1 space away from our graph on the left side, we need another point that is the same height, 1 space away on the right side of our graph. So what do you think another point on our parabola is going to be? So if this point here, our y-intercept, is 1 space away from our axis of symmetry. If we're 1 space away on our left side, we need to be 1 space away on our right side. So what is a point that could be the same height as our point on the left that's 1 space away from our axis of symmetry on the right? So we're just looking for a point. So we have this point here, and it's 1 space away from our axis of symmetry. We need to be 1 space away on our right side, so we're going to put a point right there. So that way our graph is symmetrical. So this point here that we just added would have the coordinates of 2, comma 1. So it stays at the same height as our point here, and it stays the same distance away from our axis of symmetry. Once we have 3 points, we can graph our parabola. So we just draw our parabola through those 3 points. Okay, so looking at number 1, what is our vertex? Awesome, thanks Alex. -1, 0. So remember, we changed the sign of the thing inside of our parentheses, and then we're not adding anything on the outside, so it would just be 0. What's our axis of symmetry?
-1.
Awesome, -1. So let's graph those two things now. Aiden, is this going to open up or open down?
It's going to open down.
Perfect. So we know it's going to open down. So we have our vertex at -1, 0, and our axis of symmetry goes right through it. Now, what is a point we can plug in here? So we need to plug in points to find some points on our graph. What can we plug in?
1.
We can plug in 1. So we have -3 times 1 plus 1 squared. 1 plus 1 is 2. 2 squared is 4. 4 times -3 is -12. Yep. So -12. So when we go to the right one, we need to go down 12. What is another point on our graph without even plugging anything in? We don't even need to do any more math. What do we know another point on our graph is going to be?
1, -12.
We just plotted that point, 1, -12. So that's a point on our right side. We need that same point on our left side.
1 +12.
1 +12 would be up here. So that wouldn't work. So if we're 2 spaces away from our right side of our axis of symmetry, we need to be 2 spaces away on the left side of our axis of symmetry. So Mariana, want to try again?
-1, -12.
We're at -1 here. So this green line is at -1, and we need to go 2 spaces to the left. So if this is -1, this one's -2, this one's -3. So what do you think?
-3, -12.
Awesome, -3, -12. And then we can just connect these 3 points with our parabola. Any questions on this one? All right, we have one more. Number 2. What is our vertex?
Two, 5.
Perfect, 2, 5. What is our axis of symmetry?
2.
2. So this is x is equal to 2. So then we go to our graph. We need to plot our vertex and draw our line for our axis of symmetry. So we're going to go to the right 2 and up 5. So our vertex is going to be right there, and our axis of symmetry is just going to be a line right through our vertex. Now, what is another point we can plug in for our graph here.
-1.
We can plug in -1. That would definitely work. Let's just do it. But what we want to try to plug in numbers as close to our axis of symmetry as possible, because that's going to just give us smaller numbers to work with. So we can plug in -1, but a +1 would be better. But let's plug in -1. So again, it doesn't matter what you plug in, but you just want to plug in numbers closer to your axis of symmetry because it's just going to give you smaller numbers. So we have 2 times -1 minus 2 squared plus 5. So 2 times -1 minus 2 would be -3. -3 squared is 9, and 9 times 2 is 18. And then 18 plus 5 would be 23. So we have a really big number here, so we have to go up 23. So we just need to add more lines to our axis. So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So when we go to the left 1 and up 23, we would have a point right there. So now -1 is 1, 2, 3 spaces away from our axis of symmetry on the left side. So what is another point that we need on our graph? So if we're 3 spaces away on the left side, we need to be 3 spaces away on the right side. So yeah, we're already at 2, so we just go 3 more spaces to the right. So this would be 5, and then what height do we need to be at?
23.
Perfect. So our other point on our graph is going to be 5, 23. So we go to the right 5 and up 23, and then we can just draw our parabola. Okay, one more thing we're going to go over today, and that is going to be on slide 9. So take a look at slide 9. Let's look at number 1. Do we have a max or min here?
Max.
We have a max. What is our maximum value?
-1, 0.
So our maximum is just the y value.
0.
0. Perfect. And then number 2, do we have a max or min here?
Minimum.
A minimum. And what's our minimum value?
5.
5. Awesome. So looking at number 3, we need to find our axis of symmetry, our vertex, and our y-intercept. What formula do we need to find our axis of symmetry when we have a standard form equation? What is our formula for our axis of symmetry?
-b/2a.
Perfect, -b/2a. So we get our A, B, and C from our coefficients in our function. We plug in our B and our A. So we have negative 2 over 2 times 1. This would be negative 2 over 2, which simplifies to negative 1. So our axis of symmetry is x is equal to negative 1. Now what is our first part of our vertex? What's our x value in our vertex?
-1.
Negative 1. It's the same as our axis of symmetry. What do we need to do to find our y value in our vertex?
Plug in up to -1.
So we plug in negative 1 into our x's. So we have negative 1 squared plus 2 times negative 1 minus 1. Negative 1 squared is positive 1. 2 times negative 1 is negative 2. So we have 1 minus 2 minus 1, which would be negative 2. And then last thing we need is our y-intercept. So what's our y-intercept here?
-1.
So 0, negative 1. So we get our y-intercept from our C. And now we can graph this. So first thing we're going to do is graph our vertex. We go to the left 1 and down 2. So we put a point right there. We can draw our axis of symmetry right through it. And then our y-intercept is going to be 0, negative 1. So if our y-intercept is one space away from our axis of symmetry on the right side, what does another point on our graph have to be?
-2.
So you're saying 1, 1, negative 2 here? Then that would make our parabola like this. But our axis of symmetry needs to go through the center of our parabola. So that wouldn't work.
-2 and -2.
Perfect. Well, negative 2, and then we see that this green dot is down 1, so our next point would just be at negative 1. So our other point on our graph is going to be negative 2, negative 1. So our axis of symmetry is the center of our graph. If we have a point that is one space away on the right side, we need another point one space away that is the same height on the left side. And then once we have our 3 points, we can just connect them with our parabola. Any questions here? All right, let's look at number 4. So we need our axis of symmetry, our vertex, and our y-intercept. What formula do we need to find our axis of symmetry? What formula do we need to find our axis of symmetry? Awesome. Negative b over 2a. So we get our a, b, and c from our coefficients. We have negative 8 over 2 times negative 2. So a negative times a negative just becomes positive, so we have positive 8 on top. 2 times negative 2 becomes negative 4. So what is our axis of symmetry?
-2.
Perfect, -2. So what's our first number in our vertex going to be?
-2.
Awesome. And then to find our y value in our vertex, we just need to plug in -2 into our function. So we have -2 times -2 squared minus 8 times -2 plus 1. -2 squared would be 4, times -2 would be -8. -8 times -2 is positive 16, plus 1, and then this would give us 9. So our vertex would be -2, 9. And then what is our y-intercept?
1.
1. We get it from our c, so it's going to be 0, 1. Now we can graph. So first thing we're going to do is graph our vertex. We go to the left 2 and up 9. So our first point is going to be right here, -2, 9. Our axis of symmetry is going to go right through that point at -2. And then we can graph our y-intercept at 0, 1. And what is another point on our graph have to be? Close. We're 2 spaces away on the right side, so we need to be 2 spaces away from the left side, and we're already at -2. So it's 2 spaces farther left than -2.
-4.
Perfect. -4, 1. And then we can just connect those 3 dots with our parabola. So remember, we can tell whether it's opening up or opening down just by looking at the leading coefficient, so the number out front here. So if there's no number, then it's implied that it's a 1. So since 1 is positive, we know that number 3 is going to be opening up. Since in 4, since our leading coefficient is negative, then we know that it's going to be opening down.
Okay, thank you.
But we can also just tell by plugging in our points. If our points are going, like since our second point that we plugged in here into number 4 was down here, we know that this graph is going to be opening down. Okay, let's go back to the second slide so we can graph the vertex form. So looking at number 3, do we have a maximum value here or a minimum value?
Maximum. And then minimum.
Minimum. So we look at our vertex and see that this is the lowest point on our graph, so this is going to be our minimum value. And our minimum always comes from the y value of our vertex, so what is our minimum value here?
-2.
Perfect, -2. So we always get it from the y value in our vertex. Looking at number 4, do we have a max or min here?
Maximum.
We have a maximum. What's our maximum value?
Nine.
9. Perfect. So this is our maximum value when y is 9. Okay, so here we have maximum and minimum values. So if our graph opens up, we have a minimum value. So if our graph opens up, we have a minimum. and our minimum is going to be at our vertex. If our graph opens down, we have a maximum value, and our maximum is at our vertex. The minimum and maximum values are always the y values of your vertex. So they are always, always, always y values of your vertex. So let's go back to the last couple examples that we did and name our max or min. This is where we're going to end today. There's like a few questions on the homework that ask you about max and min. I'm not sure if they mentioned the domain, range, or increasing and decreasing, but we're going to do all of this on Monday. So we're going to stop here. If the questions on the homework ask you about domain, range, increasing, or decreasing, we'll just save it for the next homework. But make sure you just answer the ones about max or min.